Okay, so now we've come to the final little video to augment the July Zoom clinic, and it was the module that seemed to draw everybody's interest the most. So of course, it was the module I had the most difficulty with. If you remember, I couldn't see in the dark. I couldn't find my pins, and it took me a while. I even took my headset off and forgot to put it back on. So there was a lot of little difficulties there. Um, but I promise I'll do better with this one this time. So let's get right with it. And I'm going to start by pulling up the code and reminding you of a few things that we've done here in the past. Immediately I open up the code and it has this include statement in it. Well, you probably don't remember, but way back in the clinic, I had us do a comparison between a recipe and a sketch, if you remember. And on the recipe side, I told you that often in the top of the recipe, it might have a statement that says, "See also perfect pie crust." So you can assume this is going to be a pie that we're making, right? But instead of trying to put in all the details here and all the ingredients here and everything that you would need to know to make the pie crust, it tells you go see this other recipe that I've already told you how to do all that. It's already there. It's pre-recorded. Just go use it and then come back here when you've got your pie crust, or refer to it as you need to during the course of this recipe. Well, the equivalent for that I told you over here in our sketch was the sketch, I should say, was the include statement. The include statement tells the integrated development compiler to go get this other piece of code and to include it with your code. In other words, we're going to borrow what somebody else has already done for us. Right? It makes life so much easier. We don't have to know all the details of how he wrote his code. All we have to know is how to talk to his code, and we can borrow it. So that's what we're going to do here. So I just wanted to kind of refresh your mind there of what we had talked about before. So here you see we're going to include some code called wire. Well, wire is all the code we need to talk on an I2C bus. And you'll see what that is here in just a minute. And then we're going to go include Adafruit underscore PMW servo driver code. That is the software that we need to drive the pulse width modulator module that you've seen during the clinic. So it comes with its own code. We don't have to write it. We just borrow it and use it. All we have to do is know how to talk to it. I'll show you how that's done here in a little bit. So let's drop down here. The first thing we need to do is tell it that we want to talk to a module. So we tell it we want to use a data type of an Adafruit PMW servo driver, and we want to call it PMW, and we want it to be an object that represents the board, the module. So we say set it up so that you can talk to a module that we plug in to this card. And so now we have an object that represents all the things the card can do. And now we can talk to it. And then this code will send commands over IC squared out to the additional module. All right, so let's just hold this here and let's take a look at some of this on hardware so that we can kind of see that relationship of what's happening here. Where's my little codes? There they are. Okay, here we see, of course, the Uno, and here's the pulse width modulator module that everybody was so interested in. And this time I promise I'm not going to screw up near as bad. And we'll go over the connections on how this all works. So the first thing, of course, is out here on the breadboard. We have the same 6 LEDs, the same 6 resistors, and we bring those 6 wires. But instead of bringing them over here and plugging them into the Uno card, we plug them in to the PMW module. And we'll go in a little bit more on that in just a second. So those connect to the card. Additionally, onto the card, you see all these connections over here. This is the communications wire and the power setup. And we'll go over that too. So if these are the outputs to the pulse width modulators, you can assume that they'll do the same function that the pulse width modulator outputs did over here on this card, right? To control the brightness and the time that the LEDs are turned on. We've just moved that function over here. We still need power though, right? So here we have 5 volts coming out to the breadboard, and we have 2 wires jumpered in here coming out to the module. Okay, and just keep these 2 wires in mind here, that they're being sourced from the same 5-volt output pin on the card. And in the next picture or two, we'll go over what they're doing for us. This white and brown wire, this is the communications wires. These 2 wires is how the Uno talks out to the module. And the last wire here is our ground wire, go back to our power source. So we have 5 volts coming into the card, we have communications coming into the card, and we have outputs going to the LEDs. Let's take a look at the next picture here. Another shot from a different angle, but it's for a reason, of course. I want you to notice that on the module you have a row of yellow pins, a row of red pins, and a row of black pins, and they're important to us. If you connect sensors to it, then our servo motor or anything of that nature, they require 5 volts to run it, and ground, of course, to return the power, and then they need a pulse width modulator to command it. So you have one of each of these in these rows here. Let's take a closer look at that. You see the yellow is labeled the pulse width modulator control. V plus is the power out to the module that you might be driving, and of course ground to go with the power. So let's back up here again, 1 second. Notice that all of our LED wires are onto the yellow strip. We're out here under the pulse width modulator. We don't need the 5 volt power out. We're going to just power it from the pulse width modulator. We'll move forward then. Past that card. Here's our communications pins. Okay, on the far end of the card. Let's back up. They're over here on this end, right here. This is all the communications that's coming in. So we have ground, which is power. We have a pin called DE. That's used for communications, but only for extremely high level communications. You'll never use it, basically said, so we don't connect anything to it. We have the SCL pin, that stands for the clock. We have to clock the signal in. And then we have the SDA, which is the data that we're sending into the card. And we have VCC. This VCC is the 5 volts coming in that powers the processing chip and all the electronics on the board itself. But it does not power the red pins that you saw out here or anything for driving the actual items that we plug into the board. That can be done in 2 places. Here you see we have V plus, which we've got connected. Remember I showed you the 2 wires that were out on the breadboard that were connected to our plus 5 volts. One of them is to the VCC to give us power to the brain on the chip, and the other is to give us power to drive the external devices, because we're not drawing enough power that we need a separate power supply. However, if we wanted to connect devices that required more power than our little Uno could supply, that's what this green terminal strip board is for. You would plug an external 5-volt power supply in here, and then you would never use this pin. You would leave this pin disconnected, and you would get that heavy current off the external power supply. Hope that makes sense to you. Now we're going to take a look where these two wires go. I said this was the I2C communications bus. So where do they go onto the Uno? We said they were the brown and the white wires, and they connect on the Uno to the same pins labeled SCL. So clock goes to clock and data goes to data. And basically, that's all you ever need to learn about I2C. You probably never have to go any deeper than knowing how to hook these two wires up. If you get that up, you'll be able to do marvelous, wonderful things with an Uno and never know any more about how this thing communicates. It's that reliable, that simple. You have to really be getting into the meat and potatoes of things before you have to start worrying about writing your own information to transfer out these wires. Everything you're going to do, somebody else is doing that for you. So relax, enjoy it. No big deal. Back it up one more time. There you see the brown and the white wires. That's the SCL, SDA wires for the communications. Again, here's the 5 volts to the breadboard. Here's the two wires feeding the 5 volts over to power the board, the brain, and the power the output pins. And then here's the 6 wires out. I might mention that also that these channels are labeled 0 through 15. Again, remember that 0 is a real number to a computer. So when it says it's a 16 channel board, it is. It's 16 channels, but you address them as 0 through 15. Let's go back to the code now. What you've seen me doing in the code is saying here, I want you to call it pulse width modulator, but I want you to know that you're going to communicate to a module out here. So create an object that represents this module so you can talk to it. All right, and the next thing we do is we drop into our setup mode. You've seen these before. Again, if this is the beginning brace, this is the end brace. So we start our communications, serial communications. Again, that's so we can talk to our serial monitor when we're ready to. Then we print out to the serial monitor, start the board test. Just a simple little thing that says, hey, I should be working. Okay. Then we say begin. We say pulse width modulator begin. We're saying turn on, listen, you're about to be used. Set everything up. Let's go. Then you set the pulse width modulator frequency. You can adjust this frequency up and down, and it's just like 50 hertz, 60 hertz. Right? We use 60 hertz. Europe uses 50 hertz. Some devices talk different frequencies. Like if you're talking to a servo motor, you probably set that frequency all the way down to 60 to represent 60 times a second. We want things to happen a lot faster here, so we've set it all the way up to the maximum value of 1600 so that we send things out quicker, or I should say the pulse width modulator time cycles are faster. Then we drop into our loop and we do our loop. Now, the loop's not real long in this set of code. Span this down just a little bit longer. Maybe I can, there we go. Got it all the way out for you so you can see the whole loop. All right, so if we start the loop here, we drop all the way down here. Everything inside of that gets repeated over and over. Serial print, so I'm going to send this out to my monitor. Begin set PMW function test. Okay, here's another one of our famous for loops, right? So I'm going to say pulse width modulator number equals 0. Okay, and I'm going to use that to represent what channel I'm talking to out here. 0 through 5, right? Because I'm using 6 channels. Okay, and so as long as that number is less than 6, I'm going to do this little for loop, right? And of course, every time through, I'm going to add 1 to the number over here. So it's 0, 1, 2, 3, 4, 5, right? And when I do, if the pulse width number is equal to 0, I need to point this out to you. It's a major distinction. It's a major point where people fail when writing code. Okay. Here you see I use one equal sign. That's an assignment operation. In other words, I'm assigning the value of 0 to this variable so that it now contains the value of 0. Here I have 2 equal signs, equals. This, in this programming language, is the comparator sign. So I'm not doing an assignment, I'm comparing. I'm saying compare the value that's being stored in this variable with this value. Okay? If they're the same, that will be true. So I'm saying if this is true, then do everything inside my braces. So if I'm on channel 0, then I want you to do this. Set pulse width modulator to, which we now know is the number is 0, to 4096, 0, or turn it fully on, is what we're saying, and delay for 500 milliseconds, or half a second. If I'm going through this for loop, and this is now 1, 2, 3, 4, or 5, this if statement won't be true. So this will fail. But I have an else statement attached to it. So if this is false, I do the else. So I drop down on let's say it's set at number 1. I would drop down here then. And on channel 1, I would say set the pulse width modulator channel number 1 to turn on at 5 and to turn off at 20 and delay for half a second. And I go through all 6 of my channels and I set these up so that they're all on. 5 of them are on at this setting, but the first one is on at full brightness. I did that so you could visually see the different channel and know, because I'm going to show you 2 different ways of doing this in the same code. And so this is a visual way of seeing how I'm doing that. I also tell you here on my serial monitor which function I'm testing. Okay, so I do that for this function test. I delay, then I come down, I do another for, and again it's the same thing, right? 0 through 6, so I'm going to do this 6 times. And I set all of my channels. See, I don't do a test this time. This is no if on assignment on this. So all 6 channels are going to see this same operation. So I set the pulse width modulator to 0 and 4096. Notice it's the exact opposite of what I did on the first one. And what that does is it turns all of them off. So all my LEDs go dark. And I delay a half a second between each one, so you see each one pulse, to off, off, wait, off, wait, off, wait, so you can see them. And it makes it just look pretty instead of them all blinking off at once. And I write out to the serial monitor, I say delay between function types, and I delay now a second and a half. So I'm going to sit there in the dark. No LEDs are going to be on for 1.5 seconds. And then I'm going to do my set pin function. Okay, and I'm going to come down here. But before I do this function, I want to take you out and explain how I know what these are doing for me and how I know how to use them. All right, so I don't want to mix the two together before you see that distinction. So let me go pull that up. What I've done is I've gone out and I searched the internet and I said, tell me, I said, how do I use set pulse width frequency? How do I use an Arduino set pulse width frequency function? And it took me to the Adafruit website, which is the manufacturer of the module that we're using. Okay, and then here's my library. Now think of a library just like you think of a library, a book library. You need information out of a book. You don't own the book. You don't really need to write your own book about it. You just want to reference somebody else's book so that you can find out the data that's in it that's useful to you. So what do? You get on your bike, you jump in your car, you run down to the library, and you check out the book. It might be how to make a pie. It might be how to repair your oven, or something of that nature. You bring it home and you study it and you pick the part out that's of interest to you and you utilize it for whatever purpose it is. Well, that's what a library does for you, right, in the real world. Well, in the software world, a library does the same thing. A library contains all the functions that the programmer wrote that you can use. But he owes you how to use it, right? It doesn't do much good if he writes all that code, but he doesn't tell you how to use it. So he writes a reference document for you that explains each one of his functions that he wrote. So here we go. I went and I found the reference library and I looked up set pulse width modulator, and it tells me, okay, I got to pass in some values to it. It needs some information in order to know what you want to do. So let's go back over here real quick and let's look at our code again. And you can see I pass in 1, 2, 3 items, right, into set pulse width modulator. That's because it needs 1, 2, 3 items passed to it. What are those items that it needs? Channel. It says here, channel that should be updated with the new value, 0 to 15. That's on our hardware. Right? Which one of these pins are you talking to? What channel are we talking to? So I have to know which one you want me to control. Then it says on and off. This is at what point do you want the channel to transition from off to on or from low to high. And here the opposite is true, right? At what point should I transition from high to low? So that's what I'm passing in. And you see over here, I was passing in 4096 and 0. And why did I pick those numbers? Okay, because it tells me right here, you can set a value between 0 and 4095. Okay, so those are legitimate numbers that I can use. And you can read all this at your own convenience. Again, you can just freeze the frame and get this address up here to go to this site to pull this up. Okay, now to go along with that, I get some examples that help me to understand this. And two real quick things. It says if you want to use these as general purpose I/O, then in other words, you just want them on or you want them off. You want them on or you want them off. Then to turn it fully on, you would tell it set pulse width modulator pin number 4096 and 0. Remember, this is the on point, this is the off point. So if I send that number combination, that pin, that channel is going to turn on and stay on. Okay. Now if I want to turn it off, I would go back to that same pin number, but I would reverse those numbers. I would set the 0 and I would send a 4096, and then it would stay on all the time. It would turn off and stay off. Does that make sense? I hope that that brightens your day up a little bit. This, I don't think you're going to use this a whole lot, but it's important that you know it. And I say it's important that you know it because you're going to see it in a lot of code. It seems to be the prevalent way that people use it. Okay, but there's another way to do it that's simpler and easier. But this seems to be what everybody has learned, and everybody is saying, well, if this one works, why bother with the other one? So they just stick with this one. And you'll see them play with these values in here, right? And I've even seen people in their YouTube say, yeah, you just put these numbers in there. I really don't know what it all means or how to use it. Just do this, okay? And everybody's happy with it. But I need to introduce you to it because you're going to see it. And you need to know that this is what they're doing. They're turning it fully on, fully off, or they're going to put it somewhere in between, like you saw me do over here with my low statement. See here, I use smaller numbers. They're legitimate, right? They're between 0 and 4095, so they're legitimate numbers. But they affect what happens to the brightness of that LED. And you'll see that in a minute when I demonstrate it. Now, that explains the half that we've done so far, right? That this is the set pulse width modulator function, right? And that we've gone through. This tells you why and how I knew how to use it. There's another function called set pin. Okay, now how do I know that? Because I went here to the Arduino library. Whoops, went to the wrong one. Here I went to the PCA 9685 pulse width module PMW library. Okay, and here it gives you a high-level overview of all the different functions that the programmer wrote that you can use. And you don't have to write any of this code. Like I said, you just have to know how to use it. So you can peruse this list and say, I'm trying to do this. Which one of these functions best kind of fits what I'm trying to do? Okay, well, here's one called begin. We used that, if you remember, way back up here at the beginning, pmw.begin. What's that do for us? At a very high level, this overview says it sets up the I2C interface and the hardware. In other words, it says, hey you, are you out there? And the board says, yep, that's me. and the two of them are happy and they know they're going to talk to each other. Okay, kind of just begins things. All right, so we can come down here, and the one we were looking at, set pulse width modulator. Okay, this looks a little bit more complicated, but when you go into it, you saw it explained it in much simpler terms. This just puts the name, the data type in front of the name. So this is an unsigned integer called number, and this is an unsigned integer this is an 8-bit unsigned integer. This is a 16-bit unsigned integer. Okay, and this is a boolean. Okay, well, no, this is another unsigned integer called off, on, off, and number, right? But look right below it. Here's the one called set pin. This is the one we're getting ready to study. And it's a helper to set PWM output. This one here. Okay. Set pin without having to deal with the on off click placement, right? Because this one, see here, requires you to set it on and to set it off. Okay. Well, this one eliminates that need. All you have to do with this one is give it a number and then give it a value that you want to set it to, and it gives you the opportunity, do you want to invert the operation? But basically, you ignore that one. And so you just say, on this channel, set it to this value. Doesn't that sound easier? It does to me. So I went to it. Right? And here it is. Happens to be, see right here was set PMW. That was the first one we just learned how to use, right? We had to give it a number. We had to tell it when to turn on. We had to tell it when to turn off. Well, here is set pin. We give it a number and we give it a value. And this is optional, so we can ignore it. You probably never want to invert the operation. Okay, so the number can be anything from 0 to 15. And the value can be anything from 0 to 4096. Much simpler. So let's go look at it in our code and see how I did it. So, going back down here, we're going to start right here, right? Delay between the two functions, and then I say begin set pin function test. Okay. So here I do the same for loop, and I say if your number is 0 or less than 6, do this 6 times. And I drop in, and now I'm telling it set pin channel number, and I send it the value of 100. So I'm sending it a legal value, but I'm not having to go through all that on-off nonsense, right? I'm just sending it a single value. Let's see what, think in your head. I really don't know how bright these LEDs are. Why don't we, let's pick a random number, 100, and let's see how bright that makes that LED. Oh, not bright enough? Let's try 200. Okay, see how much easier that could be? So and then I do my typical delay. I delay a half a second. I go up. I set the channel to 1. I do it again. 2, 3, 4, 5, and 6, right? Just like we were doing up here. But I'm not playing with all these double numbers here. I'm just sending it a simple value. And then once I've done that, right, then I come back down here and I say if it's less than 6, go in and set pin, channel number, and set it to 0. That turns it off. Right? Delay for half a second, and you see I pulse through them all and I turn them all off. That makes it nice and simple. You don't have to worry about was that on, was that off, or those two variables confused me. This is a much simpler one to use. So I hope people start picking up on that and using that one. And then here I just print out, this is my bottom delay. I'm going to stop here for a second and a half, and then I'm going to loop back up to the top, and I'm going to use the set PMW pulse again, and then I'm going to delay for a second and a half. Then I'm going to use my set pin function again. Then I'm going to delay. Then I'm going to come back up. It's just going to repeat this over and over again. So to help you visualize which function I'm using, that's why on the set PMW function, if it's channel 0, I go in there and I set that one to fully bright, and I set all the others dim. That way you can kind of visually see, oh, okay, that's the first function, and then it all goes dark, and then it'll do the second function, and it'll all go dark. Then the first LED will come up bright, and the others will be dim, and you know I'm doing the cycle over again. So let's take a look at the video and see how that actually worked. I'm going to jump in again because I always do a little preset. There we go. Everything's dark for a second and a half, bright, dim, 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 dim. So that's the upper function. And I turn them off, sits dark for a second and a half. Now you see they're all set to 100. And then they turn off, they go dark again, bright, dim, 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 dim. Okay. So you see, I'm just demonstrating the two functions you can use on that board. So there's a couple of main takeaways that I want you to learn when you get off the Uno card and get onto the module and start using it. There's a couple of things that change. The major one is you're no longer talking to it as 0 to 255. You're now talking to it in a scale of 0 to 496. That's a major change. Also, you don't do an analog read and you don't do an analog write like you did on the Arduino, on the Uno board itself. Now, you get out here and you have to use these two functions that are written for you by a completely different company. Okay, so and you're borrowing their code. I guess that's another major difference, right? You're not using Arduino code anymore, functions that the Arduino company wrote. You're actually borrowing code from the Adafruit company, and all the code they wrote to support their module. I know it's confusing, but with a little bit of practice, if you'll do this code, I promise you, in a couple of tries, you'll understand what's going on. You'll be able to use it. You may not master it. You may not even want to master it. Okay? You may just want to use it. So I hope this gets you at least to the useful level of how you can control your LEDs off of your pulse width modulator module. With that, let's go live just for one last time, just to say we did. Oh, I don't have the camera turned on. Just give me a second. I'll turn the camera on. Pull it up here. And here it is live. Bright. The rest of them are dim. I wish you could really see just how dim they were. When you do this at home, you'll really get to see how dim those LEDs are. You'll also get a very clear indication, like I was telling you before, depending on where you are in the light spectrum, how bright that LED is going to be. Some of them are much brighter than others. The green is very bright compared to the yellow and the red and the white. Okay, and so you'll see why they appear different, and that's because of the light spectrum that they're emitting. Okay, guys. So with that, let's shut it all down. This will be the end of the series of makeup videos that I hope gives you much more detail on what was happening on our last clinic. I had to cover a lot of ground, and I was finding out I was running out of time just trying to get you to the fundamentals of of how to read a program and understand it. So this time, go back to the clinic, review those fundamentals if you need to, come back to these videos and get the details of how each one works. Okay, thanks again. I hope you find these as enjoyable to watch as I had the pleasure of performing them or setting them up for you. Okay, guys, thank you. Have a good day.